Good morning and good evening, everyone. So yesterday we discussed role-based access control and role binding, cluster role binding are the resources that can give us access for our roles. Okay, so there are namespace level resources and cluster level resources. We have given role binding for namespace level access, cluster role and cluster role binding for the cluster level resources access. And yesterday we have created one user RoboShop admin that has the complete access for the RoboShop namespace. And you can create RoboShop developers. They can have limited access to the RoboShop namespace that may be only read access. So whenever a project is started, so admins will create the namespace and they will create the authentication role binding, cluster role and cluster role binding to us, and they will give us they will inform us so that we can get the access. And later we discussed horizontal pod autoscaler. Horizontal pod autoscaler can increase the number of resources, number of pods based on the traffic. It is attached to the deployment. Okay, so you can use either CPU utilization or memory utilization as the metric to increase or decrease the number of pods. Okay, so the condition is you should deploy metric server that you can get it from the internet, and then you should have resources section mentioned in your deployment YAML files. Okay, so that is about horizontal pod autoscaler, and we tested also when the load is getting increased, the number of pods are also increased. And ingress controller also yesterday we discussed. Ingress controller is like generally in AWS cloud we get classic load balancer, but here ingress controller it can sorry. Sorry. Yeah. So this is the ingress controller. So today what we do is we will use Jenkins CI/CD to deploy our applications. Okay. So I just started all our Jenkins servers. So now I will create our pipelines. So we already did that earlier. What are the stages we did? Check out, build, scan, and then package, upload to Nexus, and then this is the CI job. Okay. So this is the CI job, and this trigger CD job. So CD job, what it was doing through Terraform and Ansible, we deployed to VM. Okay. So now our applications. So our applications earlier was in VM. So now when our applications were in VM, now we decided like, okay, VM based approach is not good. So now everywhere it is Docker and Kubernetes through for microservices. It is easy for because of Kubernetes features like high availability, auto scaling, horizontal pod auto scaling, and then easy to provision, easy to increase. So because of lot of features between VM and Docker and Kubernetes, we decided to go with Kubernetes for our microservices. So now we need to deploy our applications into EKS. So if it is EKS, so this CD is going to be completely changed. And here one more stage will come up, Docker build, and then Docker push. So image should be available. Once image is available in CI, so we can deploy it to the EKS through the Helm charts. Okay. So yeah, for that thing, so we have our agent. This agent. So we have our agent. So everything is from the agent. So through Jenkins and master and node configuration, everything is running inside agent. So your agent should have this Docker build Docker command available. Your agent should have Docker command available and Helm command available, kubectl, so many things. So we already have that workstation.sh. It can install everything. So what I do here is inside our agent, so inside our agent, I'm going to install this script so that can install Docker, Helm, kubectl, all the packages required. Okay. So once this is done, like exit and log in again. Just check Docker PS. Okay, this is done. So now Docker login. I'm doing Docker login. So it was already there. Okay. So you just log in with your credentials. So once you install Docker, sometimes you may get error, sometimes you may not get the error through the Docker commands from Jenkins. What you do here is once you install Docker, just come here and then disconnect and connect again. Okay. So disconnect and launch again. Okay. So just do that. Otherwise, you may get error. Not sure. But it's always good to disconnect and then do it again. So here, let's come to our applications. So applications, I have to create repositories for everything. A CI/CD applies only for applications, not for databases. Okay, so databases are not applications; they are standalone standalone services. So this CI/CD I'm going to apply for app tier and web tier applications. Databases, I will launch it through the Helm charts. So K8 databases. This is here. I can do it through the Helm chart. So what I do here is I'll create Helm folder. So here it is chart.aml and values.aml, and we should have a folder called templates. Okay, inside templates, you can just divide this and create the files. Otherwise, single file is also enough. So I'm just mentioning stateful set.aml. So just this version, image version, you can keep outside. Okay. So this is the syntax dot values dot stateful set dot image version. Okay. So image version is, so you have to mention here the section stateful set image version is 1.0.0. So whatever the version you have. So mostly remaining everything is static here, but we need to configure our EBS. So just remember the steps to configure EBS dynamic. One is install EBS CSI drivers, provide access to EC2 servers. And what else? Create stateful set, create storage class. And what else? Can someone please ping me in the chat? So these are the admin activities. Okay. PVC is part of this one. So these are the admin activities generally. Okay. So what I do here is I just create some readme.ml. So readme.md. I will mention everything here. Okay, admin thing first. So this is dynamic only. Even for dynamic also, we need to install the drivers. You can use Helm also. Okay. Install EBS CSI drivers. Second thing, provide access to EC2 servers. So just going here. In this IAM role, add EC2 access, and we need storage class. Dynamic provisioning. Okay, so we already have that storage class, A8 resources, storage, EBS dynamic. This is the one. Okay. So what I do here is I'll create admin.aml. So inside here, this is the storage class, and I'll mention our namespace also. Okay. And so let me apply this. Yes, need to do something. Yes, EKS update config command. So at any time you can just run this command, you will get the configuration automatically. Okay, kube config. Just run this. Okay. So and I need to push that K databases. Git clone. So here is it K databases. Oh, I created this one here and read me also inside MongoDB. Just let me keep it outside. kubectl apply -f admin.aml. The namespace RoboShop is created. EBS storage class is also created. So now inside MongoDB, we have stateful set, and let me keep this outside. This one is also here. Service.aml. Okay, so nothing much to change. Everything is constant. Only one thing, this one. This is just to practice Helm charts only. Otherwise, nothing useful here. But for applications, it will be useful. Okay. And so inside chart.ml, we need to mention something, right? So here, MongoDB Helm. This is MongoDB. Sorry, subject of MongoDB, and you pull cd MongoDB Helm, and then Helm install MongoDB dot Helm list. If you do, You can see this, and kubectl get pods -n roboshop. The stateful set I didn't mention, maybe the namespace here. Mention namespace as roboshop. Okay. And service also. Otherwise, it goes to the default. Now you can just check the pods may be inside default. Hmm, Where are the pods? The kubectl get svc. So MongoDB svc is created. kubectl get stateful set. MongoDB stateful set is created. kubectl get pods. So something happened here. kubectl describe stateful set MongoDB. So there is something wrong here. We just got some extra space. Okay. So clear that. This one. Okay. So now you need to delete help delete MongoDB. Now git pull and helm install MongoDB dot. So now cube and nest roboshop. I'm moving to roboshop namespace. kubectl get pods. MongoDB still pending. Maybe the names. What is the name we have given here? EBS-SC, but the name inside this stateful set, we have given RoboShop Dynamic EBS. Okay. So again, delete this. EBS-SC. Okay, so that is the one we created, the name. Okay. So again, push, pull, helm install. MongoDB namespaces exist. kubectl get pods. So this is taking Helm list. So why is it still not deleted? Is taking the default namespace. So Helm command to select namespace. Once again, this Helm is considering default namespace. So we need to provide namespace. So let me clear this. kubectl delete stateful set mongodb service also mongodb. So now kubeNS RoboShop. I'm setting it to RoboShop. Okay, now Helm also should consider this. Now if I do Helm install mongodb dot, then Helm should install this in Mon yeah, Helm is installing in our RoboShop namespace. Okay, first you set the namespace and then you do the Helm install. Now still there is something here. kubectl describe pod. We'll see what is there. MongoDB 0. So the error is 0 by 3 nodes are available. Pod has unbound immediate persistent volume claims. Okay, so let me see the actual error. Get PVC kubectl describe. Oh, I didn't push. EBS SC. Why is it not considering here? I'll delete MongoDB cat templates stateful set. Yeah, now it is EBSSC kubectl get PVC. So this PVC is not deleted because we are mixing this with here. So one problem, so we should definitely keep it outside. Otherwise, when you delete the chat, that is not getting deleted. So now let me just get it as separate. EBSSC, and this PVC name is EBS Dynamic PVC. So this is correct, and 5 GB I'm creating. Now this claim name you should give here. The syntax again you can found just understand where should this volume comes under containers. Okay. Under containers. So this is MongoDB. PVC is EBS Dynamic PVC. Okay. Yeah. So create PVC always outside. Otherwise, this resource is not getting deleted. kubectl delete. Now I'm deleting manually. Delete PVC. It full. Now helm install MongoDB dot. Now let us see, at least still pending. Yeah, now it is getting created. Okay, so successfully we created through Helm charts. So the same way you need to create for Redis, just creating Helm folder. So it's your wish how you practice. Templates folder, and inside Helm we should have chart.yaml, and we will have values.yaml. Okay, so I'm just taking this. And inside templates, this is going to be stateful set dot yaml, and mention namespace RoboShop. So if there is no version also, we are getting it directly. And this one, we should have PVC, and we should have service.haml. So PVC, I'm just copying this from here and I'll change the values. APS, just name it as Redis PVC. And the containers, you should have volumes. The syntax, just copy it from here. Okay, volumes, this is Redis because this name and this name should match. And what is the PVC name? EBS Redis PVC. Okay, and service, I'm just copying this. Okay, stateful set is ready. PVC, again mention namespace RoboShop and service also RoboShop. Okay, stateful set, service and PVC. Just push, pull, CD Redis and helm. And we need to mention chat. There are no values. Redis and just push and pull. Okay. Now helm install Redis dot kubectl get pods. Okay, Redis is getting created. Now MySQL. So inside MySQL, I'm not disturbing the existing thing so that it will not face any problems while practice. Templates and then charts.ml values.ml. So whenever you create Helm charts, so this is the structure: charts.ml, capital C, values.ml, templates folder. So charts.ml, this is going to be MySQL. And then in templates, let me copy this stateful set. And this is, we are using it like this. Volumes, this is MySQL. And you need to create pvc.ml and service ML. So PVC, let me just take it. APS MySQL PVC. And service, let me copy the below service. And we have config map also. And create config map dot ml. And take this config map. Config map, PVC, service, and stateful set. Okay. You can just mention here version. Dot values dot stateful set version. Okay. So in values, stateful set image version 1.0.0. So this is my SQL. One thing I forgot is namespace. PVC and service and stateful set. Once you are using Helm, you can delete this manifest.yml. Yes. But I'm keeping it now because you will practice and you practice again from the scratch. That should be there. MySQL Helm. So Helm install MySQL dot. So did I mention chat.ml? Okay, done. kubectl get box. Else, let me take one duplicate session. So here we mention K9s. Okay, so we are in RoboShop namespace. Everything is getting created. So finally, RabbitMQ. So entire application, I'm just making it as Helm. Just like Redis, we'll have Helm. So inside Helm templates, and here chat.ml values.ml. So inside templates, it is stateful set.ml service.ml. Okay, stateful set. Now need this one. So image version is nothing. Just copy this volume section. EBS RabbitMQ. pvc.ml. pvc RabbitMQ. Okay. Namespace, I should mention in stateful set. And then service, let me just copy this. Namespace Photoshop. Okay. Full dimension chat.ml. No. You take chat.ml. RabbitMQ. Okay. It full RabbitMQ. Helm install RabbitMQ dot. Need to go inside Helm and I should run here. Okay, so it is getting created. Now we need to work with our applications. For example, catalog is our application. Okay, so here, first thing I should have Docker file because I'm migrating this VM based application into microservice. First, you need to have image, have Docker file for that. Photoshop, copy this Docker file. So Docker file is ready, and this Jenkins we need to modify a little bit. How can we modify here? Photoshop shared library we have. So now this is going to be not Node.js VM. So this is going to be Node.js EKS. Okay. And we need to have separate pipeline here. Node Node.js EKS dot Groovy. So one extra step will be there. So everything is same, but let me comment this deploy first. So there will be one extra step. Once you publish the artifact, you should have something that is Docker build. Okay, steps, remove this one and script. So you should have Docker build commands here. So what you do, Docker build -t join DevOps and replace this with your username and catalog. I am not hard coding it. I will just take this as component. Okay, colon, and we got the version already here. Now it is not like 1.0.0. So we'll dynamically take the version from package.json. Dot. Okay, so now our Docker is this Jenkins stage will build the Docker file and you need to push it also. So here you just make sure you log in inside agent. Okay, so just this is going to be Docker push. Okay, so we are building the image. So migrating your VM to microservice is nothing but you should have Docker file, you build the image and then you push it to somewhere. Okay, so it is Docker push. Now image is built and it is pushing. So now here also you need to change. This Jenkins is not going to be a VM based now. It is EKS. We are migrating monolithic to microservice. Okay. Component is catalog. Yes. Now catalog. Oh, we are in master branch. Yeah? Shit. Okay. Git branch. I'm just creating a branch called microservice. Git checkout microservice. Add Jenkins file. Okay, so you push this. microservice branch. Okay, let's go to catalog. So feature one, feature two, you can delete. So this is our microservice branch. We have Docker file, and then our Jenkins file is little bit changed. So that is now Node.js EKS. Okay, you should recall Jenkins now. And the first thing here you have to do inside manage Jenkins, make sure you have your shared libraries configured. RoboShop shared library. Okay, if you remember, instead of doing everything inside Jenkins file, we created a central library, and from here we are calling that, so that we no need to disturb. This is completely under developer ownership. Okay, so that is why we created RoboShop libraries. Now you need to configure them as well. So how you configure? Inside manage Jenkins system, there will be a section called library. Okay, add, so give something. What is the name given here? RoboShop shared library. The same name you should give. And then default version is master. And the project repository is this one. When I am entering the name, it is asking. Okay, apply, save. Okay, libraries are saved. Now inside RoboShop, I'm configuring catalog, multi-branch pipeline, and give our catalog. Git, this is the repository, made of credentials. That's it. Now apply, save. We'll get multiple branches. Just to cancel these things. Okay. First, we are working on microservice branch. Hmm, so it's still saying Node.js VM based. Hmm, did I push? Microservice branch. Jenkins file. This is Node.js EKS. Let me build once again. Let us see. Okay, still considering as Node.js VM based. Maybe the problem is here inside pipeline decision. I should see. I'm just giving again Node.js VM CI. It should be Node.js EKS. RoboShop shared library and so now we'll build now again. Okay, now Docker build is happening. Okay, so it is pushed. Image is pushed into Docker Hub now. So now here I'll create one Helm folder, and inside this Helm folder chart.yaml and values.yaml and templates. So inside templates, we have multiple things. Okay, first let us create them one by one. So this is going to be catalog and templates. Mm, So where is our yesterday? Yesterday, which folder we did? Um, Horizontal pod autoscaler, not ingress, not rback. K8 resources, K8 RoboShop catalog. So here we have. Okay, so now I'll keep this one by one inside this deployment dot ml namespace RoboShop catalog. This version is important here. Dot values dot deployment dot version or image version. Okay, so inside here deployment colon image version. Now I don't hard code here. I'll just keep a placeholder image version like this. I'll tell you why I'm doing like that. And this is deployment. And what else? Service catalog port. And then what else? Config map. So this Helm charts also developer ownership. He has to write. So you can guide him. Okay. And then hpa.m. You can just keep this percentage. Just for practice, I'm just keeping it outside. Dot values dot HPA job utilization. Okay. So you can change this utilization at any time. Service HPA deployment config map everywhere Photoshop namespace. Okay, so now this deployment, why I consider this image as this one is because every time the developer is changing the version, we are not keeping it static. So what we do here, so we will write a deployment job, deployment a deployment stage. Okay, so I can do deployment here itself because we are not going to work with any Terraform or Ansible, something like that. EKS deploy. Okay. First, we go inside Helm folder, and SED command, SED-I. So SED command to replace S slash. What is the one you have to replace? Image version. Replace that with this package version. Dollar package version /G. And what is that? Values.amp. So at runtime, your image underscore version will be replaced with the package.version. This is coming all the way from package.json. Okay. And I'm doing permanent change. -I means permanent change. Now you can do Helm install component dot. Okay, so now it will go inside Helm. It will replace the version with that package version, and then it will install the component. Now push it, and you do the build now once again. So this failed. Let us see what is it. I didn't push this. CD catalog push build it. So here Kubernetes, we haven't logged in from the agent. So agent here, agent is pushing, right? So obviously need to have Kubernetes authentication inside agent also. So what you do ideally, you create one RoboShop admin and you give the access to the RoboShop admin user. And then yesterday we have tried, right? So like that you can do. So for time being, I'm just giving admin credentials. Okay. Just stopping the screen. I'm just getting the admin credentials. So inside agent, I did AWS configure. Now AWS EKS update Q config, that command is there, right? Update Q config and region US East 1 and then hyphen name. This is going to be cluster name EKS spot cluster. So you should configure your agent for all the authentications. Okay, now agent is ready. If you go and deploy once again, now this time it should get success. Okay, again failure. So some numbering problem. So that one. So last time we did this as like this. Again problem. So you can just run always Helm upgrade. So that it is always safe. CD RoboShop shared library. So last time we did something with that result hell. Okay, here so here it is members, so Helm and then HPA. Just remove the quotes here and then inside values remove the quotes here. So quotes is for string. At least this time it should get success now. Okay, so now can just come here in our workstation and check catalog is running, check the logs, please connected. So now you just tell me, now we set up the pipelines. This can run any number of times. Okay. So the complete pipeline is set up. And whenever the user is changing the creating new branch and then changing the application version, simply by pushing, you can trigger this pipeline. This will go all the way to the deployment. Okay. So now this is the complete CI/CD for Docker and Kubernetes microservice. So you can say, so we develop shared libraries and we'll ask them developer to configure. That is a simple Jenkins file to refer our shared libraries. Our shared libraries have the stages, checkout, and then install dependencies, unit testing, sonar scan, building, static application security testing. We'll push the package to the Nexus and we do the Docker build and we push it image to the repository and we will trigger, we will have Helm charts to deploy the application into the Kubernetes. These whole stages, we configure them as shared libraries. So we have shared libraries for Node.js, we have shared libraries for Java application, so we have shared libraries for Python application. Okay, so like how we did, I can create the. So now the shared libraries are for Node.js. Similarly, you can create for Java, we can create for Python. Okay, yeah. So I will do this. And by tomorrow we can end this. Okay, so I'll write the pipelines today itself and then I'll come to the session tomorrow. Okay, so because we cannot spend time again to do the same thing again and again, I'll just copy paste few stages and few stages will be changed. For npm, for Node.js it is npm install, for Maven it is Maven package, something like that. Okay, any questions? Is this clear? Whatever the concepts we learned, Helm charts, and the same thing I configured in the pipeline only. I didn't do anything new today. Any doubts you can ask. Otherwise, we can end the session for today and you can start doing the same thing. So what you do again for now, cart and user, the same way you will do the Docker file, you will do the Helm, change the values, and the same component will work, right? Node.js case. Okay. So if no questions, we can end the session. No questions, everything is clear. Expecting at least one question. No. Okay, then we can end the session. See you in tomorrow session. I will do the pipelines. I'll push it to the GitHub. Okay, that's all for today. Bye bye. See you.